Numbers, data, clustering. It can feel overwhelming, right? But not with hierarchical clustering. This technique simplifies grouping data into something visual and intuitive. Welcome to day 19 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we'll break down hierarchical clustering, code it from scratch, and compare single and complete linkage. Stick around. You'll master it in no time. Let's start by importing the essential libraries: Pandas for data handling, NumPy for calculations, Matplotlib, and Seaborn for visualizing insights beautifully. Now, we load our dataset with pandas and quickly glance at the first few rows using head. This gives us a feel for the data structure. Here, we check the dataset's shape and column names to understand its structure. Then, we simplify column names for easier handling while coding. We summarize the dataset with describe for numerical stats, info for data types, and check for missing values to identify potential issues. We create a pie chart to visualize gender distribution, showing proportions with percentages. This helps us quickly understand the dataset's gender balance. We loop through key columns to plot histograms, analyzing their distributions. This reveals patterns, outliers, or skewness for variables like age and income. Here, we use Seaborn's pair plot to explore relationships between features, with points color-coded by gender. This visually highlights any trends or separations. We plot boxplots for each column to visualize data spread and detect outliers. This helps in understanding the range and distribution of key variables. Now we calculate the correlation matrix and visualize it with a heat map. This helps us spot strong or weak relationships between variables at a glance. Here, we use Label Encoder to convert the gender column into numerical values. This step is crucial for preparing categorical data for machine learning models. We create a copy of the original data, remove the customer ID column since it's not needed for analysis, and preview the cleaned-up dataset. We perform hierarchical clustering using the single linkage method and Euclidean distance. The dendrogram visualizes the cluster's relationships, showing how data points are grouped. This helps us understand the data structure, revealing how different observations are connected to each other based on their similarity. Here, we use complete linkage for hierarchical clustering. The dendrogram shows how the data points are grouped using maximum distance, offering a different perspective on the relationships between observations. Now we apply average linkage to group the data. The dendrogram illustrates how the clusters are formed using average distance between points. Here, we cut the dendrogram into 2 clusters using cut tree. This labels each data point according to its assigned cluster, ready for further analysis. We add the cluster labels to our dataset, creating a new column. This shows which cluster each data point belongs to for further analysis. We use boxplots to compare the distribution of each feature across the clusters. Helping us understand how the clusters differ in terms of key variables. And that wraps up our deep dive into hierarchical clustering. We've seen how to implement it, visualize the clusters, and analyze the results. But we're not stopping here. Next up, we're tackling a real-world unsupervised learning project. You'll see how these techniques come together to solve complex problems. Click on the screen to continue, and don't miss out on the next exciting chapter.